the two coils connected in series, which are labeled as L1 and L2, they are winded such they have the same direction. Each coil has a self-inductance of 4 Henry. So that's given, that self-inductance 4 Henry, same for both the inductors. If the coefficient of coupling is 0.75, the coupling coefficient is 0.75, which is usually represented by K in lowercase. For mutual inductance, the equivalent inductance of the series combination is, we have to find out the equivalent inductance of this series combination. So the very first thing we need to do is to find out the mutual inductance. And the formula to calculate the mutual inductance equals coupling coefficient times square root L1 dot L2. There are two inductors, L1 dot L2. And notice here the two values are same, right? So if because the two inductance values are same, I can rewrite the above equation as maybe replacing L2 with L1 since both are same. So that makes it L1 square. This square will cancel out with this under root. So I basically have KL1. If I plug in the value, K being 0.75, K being 0.75, L1 being 4. If I do the math, I basically get 3. Mutual inductance, that of 3. Now, what is going to be the inductance in series? Now, simply inductance in series is just a sum of all the inductance as well as the mutual inductance. Now, there are two inductors, L1 and L2. So basically, equation will become L1 plus L2 plus there are two inductors and their mutual inductance. So let's plug in the value in this equation. So we have L1 being 4 Henry, L2 being 4 Henry as well, plus 2 mutual inductance was calculated, that came out 3 Henry. So we have 3 Henry here. And if I do the math here, 4 Henry plus 4, that's 8. 8 plus 6 is 14. 14 Henry, and that is your answer right here.